Imagine summing numbers forever. Does the total explode to infinity, or does it settle on a specific value? Let us investigate the infinite series 1 plus 1/2 plus 1/4 plus 1/8 continuing indefinitely. This is a classic example of a geometric series, and we can visualize it perfectly using a simple line segment of length 2. Watch as we start at 0 and move a distance of 1 unit to the right. This represents our first term. We have exactly 1 unit of distance remaining to reach the end of the line. Now add the second term, which is 1/2. See how we cover half of the remaining distance. We are now at 1.5. The next term is 1/4. Watch as this segment fills half of the space that was left over. We are now at 1 3/4. Notice the pattern emerging here. Every time we add a new fraction, we're simply taking half of the remaining gap and filling it in. The term 1/8 fills half of the remaining eighth. The term 1/16 fills half of the remaining 16th. As we speed this process up, watch the empty space on the right shrink. It gets smaller and smaller, approaching 0. Because we're always cutting the remaining distance in half, we never actually overshoot the number 2, but we get infinitely close to it. In the language of mathematics, we say this series converges to 2. We can prove this rigorously with a clever algebraic trick. Let us define the letter s to be the value of our infinite sum. So s equals 1 plus 1/2 plus 1/4 plus 1/8, and so on. Now watch what happens if we multiply the entire equation by 1/2. The left side becomes 1/2 s. On the right side, every number is cut in half. The 1 becomes 1/2, the 1/2 becomes 1/4, the 1/4 becomes 1/8. Now place these two equations on top of each other. Notice that the new sequence is identical to the tail of the original sequence. If we subtract the bottom equation from the top equation, see how the infinite tails cancel out completely. The 1/2s cancel, the 1/4s cancel, the 1/8s cancel. Everything vanishes except for the very first term, which is 1. We're left with the equation s minus 1/2 s equals 1. Since a whole minus a half leaves a half, we have 1/2 s equals 1. Multiplying both sides by 2 gives us our final answer. The sum is exactly 2. If you enjoyed this explanation, hit subscribe and check out our other math videos.